So we're still on solving equations, but this is part 2. Woo! Today we're going to be solving equations, but with using exponents and fractions. A few things to review here. First, when we're talking about x squared, when we want to get rid of a square, we have to do the opposite of squaring it. So that would be the square root. Now you have to be very careful when you're taking the square root. When you take the square root of a number, I would have x is equal to 4. However, if I plug this back in, 4 squared is going to be equal to 16, but so would negative 4 squared is also equal to 16. So whenever you have an even number or an even root like this, you always are going to have a plus or minus. So in this case, this would be x is equal to plus or minus 4. So even root would give you plus or minus because it could be either or. Just like for the second one, if I were to do my factor tree and I have 4 and 4, 2 and 2, so I have one group of 4 here, so I'm dealing with 2. However, again, if I take the fourth root that's even, I can have both plus or minus. So x is going to be equal to either plus or minus. So again, if it's an even root, it's going to be plus or minus. So we talked about the third, or the cubic would be the third root. That's the opposite. So exponents and roots are basically opposite of each other. And for an odd root, if it's going to be a positive number, your answer should be positive. So in this case, this answer would just be 3. In this case, I would have 2 and 4, and then 2 and 2, and since my original was negative, x would be equal to a negative 2. So, just a little review, when I'm having an odd root, it could be whatever it begins with. So if it begins with negative, your ending number should be negative. Even root, you should always include a positive and negative answer. So when I'm dealing with a problem and I have exponential fractions, first thing you want to do is isolate just the exponent. So I want to get rid of this 2, so that 2 is being multiplied, so I have to divide both sides by 2. So now I have x plus 3, that whole thing raised to the 2/3 power is going to be equal to 4. Now when you have your exponent, you want to get rid of your exponent. So you have to take the reciprocal. The reason why it's the reciprocal, if you look here, is because once you multiply by the reciprocal, it will end up to be 1, because a power to a power you multiply. And whenever you have any number raised to the first power, it's just the original. However, you have to be very careful when you multiply with the reciprocal, because if it's an even root, it should be positive or negative. How do you know if it's even? By the fraction. So even root means the denominator is going to be even. So the number on the bottom of the fraction. So the next step I have here is I'm going to raise the whole thing to 3/2 because the reciprocal is going to be flipping it. So I'm going to raise the other side by the same thing, 3/2. So when I multiply this through, power to a power here, those cancel each other out because I would have 6/6. So x to the third, and this would be 6/6, which reduces to be 1. So it's just x plus 3. You don't need those parentheses on the left-hand side, but I included them. So here would be 4 to the 3/2 power. I can rewrite 4 as 2 squared for prime factorization. So now I have 3/2. So now again, the power to a power, I'm going to multiply, and I would get that this would be 2 to the 6/2. Now when I look at this, I look at the bottom of the fraction. Is that even? Yes. So I should have a positive or negative here because I need both. Whenever it's an even root, it can be either answer. So my next step to get x by itself is to get rid of this adding. So I have to subtract 3 on both sides. So now you're actually going to have 2 answers. X is going to be equal to, and you have to split this problem off into 2 parts. So you actually have a positive. This was actually going to reduce to 2, and 6 divided by 2 is 3. So that would be 2 to the third. So that's going to be 8. So it's going to be minus 3 or negative 8 minus 3. So your two answers here would be either 5 or a negative 11. Then you should always go back and check your work, and I will show you an easier way on a graphing calculator, TI-84 or higher, how to do that. So right now I want you to try this problem all by yourself. So again, first isolate the exponent and take the reciprocal. So right now try to solve this by yourself and see if it matches my work. So you should have gotten that x is equal to 7 or negative 9. So it's the same process, and since this was an even root, you needed to make sure to have a plus or minus. So you have to actually simplify out the 2 to the third, so that was my 8. So it's 8 minus negative or minus 1 or negative 8 minus 1. So this problem is kind of like the same thing, except two things are going on here. I want to isolate this. And I'm going to do two steps here. I'm going to subtract 1 over. So I'm going to have 3. And the next part I'm going to do is rewrite this index as an exponent with a fraction. So this would be 3 times, it's going to be x plus 1. That whole thing is raised to the third. But also, that whole thing is raised to the 1/5. Because the index of 5 makes the 1/5 exponent is equal to, subtract 1 from both sides, is 24. So I'm going to do two steps again. I'm going to divide this side by 3 and divide this side by 3. And when I rewrite the part on the left, I'm going to have the x plus 1, but a power to a power, I'm going to multiply those. So that would be like 3 over 1 times 1 over 5, so that's 3/5. That's going to be equal to 8. So my next step is multiplying by the reciprocal, so it's 5/3, and this is an odd root. So I'm just going to have one answer here. So I'm going to multiply this side by 5/3. So on the left-hand side, I just have the x plus 1, because when I multiply these two together, I would get 1. And then 8 can be rewritten as 2 to the third. And I'm taking that to the 5/3. So on the left-hand side, I still have x plus 1, and then I would have a power to a power I multiply. So this would be 2 to the 15/3, or x plus 1 is equal to 2 to the 5th. So I actually have x plus 1 is equal to 64, because that's 2 to the 5th, and subtract 1. I get x is equal to 63. And again, I only have the one answer because of the denominator. The denominator was odd. So if it starts out as a positive number, your answer should be a positive number. So that is all I have for you today. Make sure you took great notes and have a great evening.